Hello, my name is Betancourt.
I'm Enzo.
I'm Mateo Diaz.
Our group is working on the integration of a solar thermal collector system for a FDOT Trolley. So what exactly are we doing? We have designed and will manufacture a solar collector that will power the AC system and all other electrical components of a trolley. Here we have a breakdown of team responsibilities. Even though we have assigned a task to everyone, we're working as a group in order to make sure that the project comes up correctly. Before we get more into details about our design, I'm going to give some background on how the trolley system has developed in Miami-Dade County. The first trolley was introduced in 1906. It was electrically powered. This stopped working due to a lack of popularity. In 1915, they came up with a design that would run on batteries and would also run on rails. In 1922, they came up with a design of overhead wires. This design seemed to be a problem due to the wires around the city. Then it wasn't until 2012 that the city reintroduced trolleys. These are the ones we see around right now and are run by diesel. The goal of having a trolley in the city is to provide a cheap transportation system to underserved areas of the county. For our goal and motivations, our first goal is to create a 100% electrically powered trolley. We will do this by integrating the three forms of heat transfer. Also, we would like to generate enough energy to charge the batteries of the trolley for nighttime or rainy days. Then we would like to take advantage of Florida's location by maximizing heat absorption from the sun. Then we want to offer an eco-friendly transportation to the state, and actually the city of West Palm Beach is already approaching this by working their trolleys with liquid propane, which takes us to our last goal, that is reducing emissions of CO2, as we found out that Florida is the number 6 contributor in the country of CO2 emissions. For the estimated energy consumption, we know that an electrical trolley requires 2,500 watts to run. Then an AC system requires between 450 and 850 watts. Finally, the pump, which we'll need to move the fluid, takes around 150 watts. This gives us an energy need of 3,500, an estimate of 3,500 watts. So our goal will be to create a solar collector that will have between 20 to 30% efficiency.
In order to maximize the energy production or efficiency of our entire system, we are also going to be incorporating the use of solar panels, as well as the capability of being able to plug in the trolley into a DC power source for those rainy or cloudy days. The standards that we're following for the development of this thermal collector are stated by the Florida Solar Energy Center. Even though these standards are mainly related to commercial or mass-produced thermal collectors, we still have the need to comply by these standards in order to guarantee that our thermal collector complies with safety regulations. The first standard that we have listed up here basically describes that any thermal collector that is being produced needs to be certified by the FSEC. This is to guarantee that once the thermal collector is produced, it complies with safety regulations. The second standard that we have basically describes that once a thermal collector is being installed, the installer needs to follow the instructions as stated by the manufacturer in order to guarantee that once installed, it complies with fire safety regulations.
Okay, so this was our first proposed design. We decided to go with a parabola tower system as for our first design, mainly due to this fact that no matter where the sunlight was located throughout the day, except for at night, that it will be able to strike the system at any given point in time. You have then a piping system will then run from top to bottom that would wrap around the whole entire system. This piping system which would be used to transport the fluid in which we are using to heat up. We also wanted to encompass a casing system around the actual system for two reasons. One, to protect it from the outside elements and then also from falling debris to prevent damage to our system. Also to produce a greenhouse effect in order to maximize the amount of heat in which we're able to generate inside our system. Now, this was our second design and our final design as well. We decided to change the design due to height restrictions because throughout the city, there are different elevations in height, and then we didn't want to risk the factor of actually damaging our system due to, foreign objects or outside sources. Then, similar to the other design, our piping system will run along the top of our system, and then as well we'll have a single piping system located at the center underneath. Now, this piping system underneath will be important because it will serve as a preheating source factor so that when the water is being transported from the reservoir to the actual system at the top, and then it will generate throughout the rest of the system. And then we also wanted to encompass the same casing system, housing system for the two effects that we discussed in the first design. Now, these are just different angles of our actual system in which we hope to implement. And as Mateo mentioned earlier, we wanted to also incorporate solar panels. We wanted to incorporate it actually between the piping system so that to utilize and maximize the amount of energy in which we're able to take out of the whole entire system in general.
For the proposed materials that we have for the development of this thermal collector, the three main materials that we're going to be using are copper, glass, and high heat resistant thermoplastics. Being that the trolley is going to be used in Miami, a high temperature area, for the main structure of the thermal collector, we are using a tempered glass. Tempered glass, which is heat treated, which makes it about 4 times stronger than regular glass. Makes it a more feasible option, being that it is heat resistant, it is lightweight in a way that is not going to affect the performance of the trolley, as well as going to provide a good heat conduction throughout to maximize the efficiency of our entire system. Now, the piping that's going to go over the structure, as well as the straight pipe that's going to run underneath in the center, is going to be made of copper. We chose copper because it is a lightweight metal, it is heat resistant, as well as it provides a great heat conduction, which yet again will maximize the entire efficiency of our whole system. Now, as Enzo mentioned it, the casing that we're going to have over the whole system which is going to provide that greenhouse effect, is going to be made of high heat resistant thermoplastics. Now, this is a projected timeline for completion of the project. Up to this point, the main structure or base of the project is already complete. The following steps include CAD simulations, manufacture, assemble, and prototype testing. Now, throughout the development of this project, we have learned that working in a team is really important, especially being that we are each from different backgrounds and possess different abilities. Also, being that since we each have different schedules, we learned that communication is key when it comes to organizing and developing the project in an appropriate manner.
So globally, we could all agree that pollution is one of the main issues that we face today. And also that, just like Florida, countries around the world share the similar trait. So with our design, we want to help create a more eco-friendly mentality in order to get our design out there and then thus help push the actual use of renewable energy, as well as since our design is cheap and easily accessible from different places around the world, then anybody could take this system, possibly incorporate it into a static system to possibly use it to generate electricity in homes or impoverished neighborhoods in order to utilize it for the best possible use in which they see fit, and thus having a positive effect on the world in which we live in. Thank you very much. Thank you very much. Questions or comments?
What are you going to do with the hot water? You're going to make it, you have a steam turbine somewhere that's going to make electricity? Or?
So the hot water would actually be used to directly power the AC system which we're going to incorporate. So the group before us, that we're going to be working with, their system will run off of the hot fluid in which we're actually extracting.
You said in the beginning you also were going to power the trolley.
Yes, so that's why we wanted to incorporate the solar panels as well to serve as like a secondary source of electricity in which we're generating, because we do have to generate a lot of electricity in order to power the AC system, to power the trolley, and then also any other small electrical components on board. That's why we also gave the design of implementing a plug-in system for that if it was cloudy or we aren't able to generate solar energy, that we also will still be able to use the trolley when in those conditions.
You talk about one of the goals being to get 20 to 30% energy efficient for your thermal solar collector. Could you talk a little bit more about how you plan to achieve that?
Well, mainly just as Enzo explained, the main thermal collector, which is run by the hot water, hot liquid, is our main goal for powering the AC system, but we're also incorporating all the other factors like the solar panels or being able to plug it in to a DC power source, all those factors will help us increase that efficiency.
Yeah, so we're just basically going off of estimated results in which were gathered through research and data, and then just trying to offset them out, just how everything actually works on a whole. So like once we have actual testing and then we have prototypes and able to actually properly assess that situation, so we could get a more of an exact estimate of what it would actually cost to generate that. But that's just an estimated range in which we want to try to accumulate as far as efficiency goes.
Also, could you talk a little bit more about the economics about this? And how what information do you have that people are going to be using that trolley? You know, we have the metro rail, and one of the criticisms of the metro rail is that not enough people go on the metro rail that should. If you're going to have a system that you're going to have with this trolley, how do you know it's going to be economical for us to have something like this?
For example, the city of Rudel, the trolley system that they have, that one's free of charge. So if we incorporate it, we take that same idea or
Possibly replace what they have
Exactly.
already and incorporate and keep the same popularity.
And actually
But this is for Miami, right? You're talking
Yes,
about
yes,
Miami,
yes,
Well,
right?
actually, the first trolley that we're gonna work on is here at FIU. It's downstairs, so we'll integrate all the system to that trolley, and that's gonna be our first test for the city.
And you think it's going to be more economical going to your system than what they currently have?
Because currently how we have it, we feel that it would be more economical in the sense that since the current trolleys that they run are using diesel, we feel that as far as money goes, they will save in that aspect. And plus, we will hope to possibly replace the system in which they have altogether. So we feel that as far as economically and popularity goes, it will keep the current popularity aspect in which it has, since it is a cheap source, if not free source of transportation throughout the city, and then just try to implement those same strategies in order to get that across.
Okay, the question I want to ask is, have you scaled the project? In other words, how big does the solar cell have to be in order to make 3,500 watts with a 20 to 30% efficient solar cell? How much tubing do you need to have in order to produce enough hot water to run that air conditioning system?
I mean, so far we don't have the exact data. We do know that the
Ballpark.
Yeah,
Because I mean,
that
am I
dimensions-
looking at a half a football field of solar cells in order to achieve this, or is it going to physically fit on top of us?
Well, the main structure that you see from the poster, that whole structure basically covers the whole roof of the trolley, which is, we estimate, we don't have the exact dimensions of the trolley yet, but the estimated is about 10 feet long, 6 feet wide, and since the trolleys have the little offset on the roof, that's why we have that parabola shape, which also helps for the direction of sunlight. It's about 2.5 feet tall. So that's our estimated dimensions for the actual structure. The length of the piping, we estimated a calculation of.
It'll pretty much run along the whole entire length of the actual trolley. So the piping system is going to be.
But will
fairly
that produce
extensive.
enough energy to do it, what you're asking?
See, that's the thing in which we have to discover through actual testing, in which we.
Should be able to figure that out, experiment. Pierre? Okay.
I mean, there
Second question, and my last question. You say that the cell is parabolic. How are you going to produce the glass plates parabolically?
Well, those, for this we need to find a third party that works with glass, either shower cabins or they produce glass for automotive cars. And when they form those glass plates, they put them in a furnace which makes a shape regarding of the radius that you need it for. For that case, we need to find a third party that we can basically hired for them to make that.
Are you
that shape
working with a
for us.
budget for this program? How much money are you working
It
with?
is funded,
It's fine.
it is a funded project, so,
Okay, thank you.
thank you. Thank you.
Thank you.